at Math 2023. All right. We're looking at question 4. And if time permits, I go to question 5. So let us go. Question 4 says a function given by, so we have a function that is given by y is equal to x squared plus bx, x squared plus bx plus c, has a gradient of 9 minus half x and a stationary value of 5. And this would have meant that at the stationary point, y is equal to 5. So we want to make note of that. All right. Determining the values of a, b, and c. There are more than one approaches. We could equate coefficients here, or we could integrate. The gradient, because this is dy dx. All right. So whenever we get the gradient function, we actually would have gotten dy dx, which is 9 minus half x, right? 9 minus half x. So this is actually dy dx. A way in which I could go back to the original form is to integrate. I can integrate 9 minus half x, right? dx. I could integrate this to go back to the original form and then use a point to find the original equation and then pick up my a, b, and c. So there are two approaches. So I'm going to just integrate here. So if I'm going to integrate this, I'm going to get y is going to equal to, when the integral of 9 is 9x. The integral of this is going to be minus a half x squared. And then I'm going to divide by 2 again. All right. So we're going to have that. All right. And then there is a plus c. So let me rewrite this. We have, what we have here is y is equal to 9x minus 1/4 x squared plus c. So that's what we would have right now. From this, we could see where we can pick up from this my b and my a. We're seeing that already, right? So currently, we could say that a is the coefficient of the square, so it's going to be negative 1/4. B is actually the coefficient of x, and it is 9. We have those. All right. In order to find the c, I'm going to understand what they gave me here. So I'm going to apply some understanding. All right. dy dx, right? dy dx is my gradient function, but they use stationary value. So when I have my dy dx or my gradient function, if I'm at a stationary value, it means then that this gradient function at the stationary value, it is equal to 0, right? So stationary would have said that, all right, the curve is not increasing or decreasing at this point. So then I could solve this to find the x value to match with this to get a coordinate at the stationary point. And when I get that coordinate, I'm going to use it back in this to find c, all right? So then let's go. All right, so let us solve. So basically, depending, I could just say 9 is equal to positive a half x, right? And then I could multiply both sides by 2. And so 18 is equal to x. So it means then at the stationary point, the coordinate at the stationary point is 18 along with 5, right? So now, so this is the x and that's the y value. So what we could do then is to find c. So we want to find c at this point. We're going to take this, which is y equal to 9x minus 1/4 x squared plus c. I'm going to substitute here, right? So I'm going to substitute this point. So 18, y is 18, so y is 5, I should say. So we're going to say 5 is going to equal to 9 times x, which is 18, minus 1/4 18 squared plus c. So we want to put that together. Let's take our time. All right, 9 times 18. 9 times 18. So let me rewrite this. So 5 is equal to 162, right? 18 squared divided by 4. All right, so I get 81. So minus 81 here with a plus C. Solving for C, I'm going to have, if I'm solving for C right there, so basically I'm just going to have a 5 minus 162 plus 81. So I'll have C alone. All right. So let's go for that. 5 minus 162 plus 81. So I'm getting a negative 76, which is equal to C. All right. So then if I'm going to write, so we're seeing here, as you can see, we're getting the C value. So basically then A is equal to 9, B is equal to, hold up, let me write back. A is equal to negative a quarter, my bad. B is equal to 9, and C is equal to negative 176. All right, so I'm just saying this is one approach, right? There's another approach that we could have used to still get our A, B, and to get this C, we definitely would have to find the point and substitute it. But we could have done this quickly to find the A and the B. I could have taken just another approach, right? I could have taken y equal to a x squared plus bx plus c. I could find the derivative of this, so dy dx is going to equal to 2, all right, 2ax plus b. So this is the dy dx, which is going to be equivalent to this same dy dx. I'm going to put the x's, line them up, so I have minus a half x, right? And I'm going to put the positive 9 at the back. So at this moment, we're seeing where the b is equivalent to the 9, because this is the same function expressed using different variables, but the idea remains the same. So we're seeing that we still get 9 to be the b right there. For the a, we would have to take this part and equate it, right? So you could see then that 2a is equal to negative a half, right? So if you divide by 2, to divide means divide by 2 means to multiply by a half. So a is equal to negative 1/4. And that would have been just the other approach in finding my a value here, as you could see. But there are various ways to get there. It's just saying that, multiple ways of getting there. All right. Now, this question says here that, hey, all right, determine the nature. If you're going to determine the nature of the stationary point, what we want to keep in mind is that we're going to take the second derivative, right? Right? We're going to take the second derivative. If our second derivative is less than 0, we have a maximum. If my second derivative is greater than 0, we're at a minimum. If my second derivative is equal to 0, we have an inflection, right? We have an inflection. So we're going to check to see what we have. So remember now, first derivative was 9 minus half, right? 9 minus half x. So I'm going to take the derivative again. So my second derivative is going to equal, so the derivative of a 9 is gone. The derivative of negative half is negative half. So you could see that this value here is less than 0. which means that we are at a maximum, right? So the nature of that point is that we are at a local maximum. Right, so we're at a local maximum for that. All right, so let's continue. All right, local maximum. Next question. All right, so this question states here, as we're looking at. All right, so this question states that a drone, it says a drone tracks the movement of an object in motion on ground. The following movements are recorded. It moves at a constant velocity of 4 meters per second for 5 seconds. Its velocity increased uniformly for 3 seconds to 10 meters per second. It moves at that velocity for 7 seconds. It slows down until it comes to rest after 4 seconds. Sketch the graph. All right, so they gave us this to put it on. So obviously it's going to be one of those nice sketch. So, all right, so I have this here. I'm going to do the thing on. All right, and here's the information. I'm going to try to put it here. Somehow put it at the side. Could go back to it to have a visual. All right. All right. So first it says a drone moving. So it moves at a constant velocity of 4 meters per second. So you're going to be start. So let's put on. So we're going by. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, so let's go. So we want 4 meters per second, and we're going for. All right, so let us go with this. We're in 4 meters per second, and we're going for 5 seconds. So we're starting here. So 5 is going to be halfway between the 6 and the 4. All right. I'm going to put this in blue. I just put it in red. All right. All right. So what we have down here we have a 5, right? This is 5, right here. So it does that for 5 seconds. And its velocity increased uniformly for 3 seconds until it reached 10 meters per second square. All right, so 3. So we're talking about it's going to do that until it reaches 8. So it's going to be a straight line from here. And we're going to bring this to 10. But at the same time, you're going to have to make sure that we check the time right. 3 more seconds on 5 will give us 10, right? So we're right here. They're right there. So we're talking about moving from 5 seconds, 3 more seconds will put us to 8, right? Hence we are at 10 meters per second right there. So that's good. Let's continue reading. It says it moves at that velocity for 7 seconds. So 7 plus the 8, we're going to 15. So it's going to be constant, which means that we're going to have to draw an horizontal line. So it's going to be moving at this until it reaches 15. 15 is going to be halfway between 14 and 16 right there. Right? Right there. All right, let me bring this down. Right here. All right. All right, and then we are at 15 down here. So it's right here now. All right, so we could drop. All right, we could drop a broken line. All right, we could drop a broken line right there. that is our 15. And I believe we could have dropped one here as well for our 5, all right? So we have some, all right, there we go. And then now, for the last part, it is saying now that it slows down until it comes to rest after 4 seconds. So we're going to go to 19. All right, 4 seconds and 19. So we're bringing this down to 19, which is right here, all the way to 19, halfway between 18 and 20, right there. We'll come down to 19, right? All right, so that's 19. So we have our 19 here. All right, so if we put on, we could take off the unnecessary things if we want, all right? So let's put on, let me take off the unnecessary markings. So let's put on the ones that I need. So this was 5, all right? 5, and then this was 8, and then this goes up to 15, and then 4 more on the 15 gives us 19. So that's the real timeline, and this is the sketch of the information. So we just read, follow, and collect those marks. So that's the diagram that we're looking at. Next question now. So for the next question, it says here, so they're asking us to do a few things, right? All right, let us look. 1, calculate the distance traveled by the object in the second part of the journey. Talking about the second part of the journey. The second part of the journey is definitely this section. So I'm going to just highlight it. The second part of the journey is in this section right here. Right here. This is the second part of the journey right there. And if you look, the distance traveled in a velocity or a speed against time. The distance traveled is the area, all right? It's the area covered of that shape that you're seeing under the curve. So we're seeing a trapezium where this side length is 4, the other side length is 10. Those are the two parallel sides, and then the height is 3 right there. Right? So basically, half the sum of the parallel sides times the height should give us that. So we're talking about the area. We want to find the area of that shape, and it is a trapezium. And the formula is half A plus B times H. Remember, A and B, the parallel sides. So half the 4 plus the 10 times the 3. So let's put that together. 14. So 4 plus 10, 14 divided by 2 is 7. 7 times 3, that is 21, right? Meters. Right, so we have 21 meters right there. So that is the distance covered in the second part of the journey. The next question went further, and it says here, determine the object's acceleration in the final part. So you want to go where the final part is, right? Let's go where the final part is. Final part. So let's take a look. The final part, we want to do the acceleration in the final part. So we could do it at the side. The acceleration in the final part. We could do it right here. Acceleration is actually the gradient of the gradient of that line that you're looking at. So we're talking about, remember, gradient is y2 minus y1, all right, over x2 minus x1. You could look at it as change in velocity over change in time. It's the same concept, right? The velocity is the horizontal, is the vertical axis, and the time is the horizontal. So we're talking about you're coming from 10 here, but we're talking about 15, 10. So if you're looking at a coordinate, that's 15 on the x with 10. That's 15, 10 right here. And we're going all the way down to 0, 19. So it's 15, 10 with 0, 19. right? I'm saying you could see this 10 is the linking to the 15. And when we are here for our final journey, that's a 0, 19, right? So you could label those. You could say, we could say x1, y1. We could say x2, y2, right? So y2, 19 minus 10 over x2, 0 minus 15. And we're looking at 10, that's 9 over negative 15. All right, so the acceleration is actually, as you could see, it's a negative because it was slowing down. So we're talking about negative 9, 930. And you could cancel them by 3, 3 into that's 3, 3 into that is 5. So you're talking about negative 3/5 or negative 0.6. So it's up to you. You could represent this many ways per second squared. So we could have a negative 3/5 or negative 0.6 meters per second squared. Let me just write this proper. Negative 0.6 meters per second squared. Final. All right. All right. So there it is. That is question 4. Question 5 says, consider a truck moving along meteorized racing course with an acceleration at 9t squared plus 2t minus 1, where t is time in second. Assume that the speed of the truck is measured in centimeters per second. Outline an equation for the speed of the truck will be found. How the speed of the truck will be found using the equation. All right. What we want to understand is that the speed of the truck here is linked to velocity, right? So then velocity is actually the integral of acceleration, right? So velocity is the integral of acceleration. So it means then velocity speed. So it means then that this is going to equal to the integral of. So we want to integrate 9t squared plus 2t minus 1. We want to integrate this now. So what are we getting? We're getting that our speed is going to equal to, it's going to be 9t. We're going to integrate this, increase the power, divide by the new power, plus 2t squared divided by the new power. Integral of 1 is t plus c. So this is going to give us 3t to the third plus t squared minus t plus c. This is the speed. There isn't any additional information given. So we're going to assume that c is 0, right? So we're going to assume that c is 0 here. So basically, let's write the final thing, that our speed is equal to 3t to the third plus t squared minus t. Find the speed of the truck at 10 seconds. So when t is equal to 10, so basically then we have the formula. We're going to substitute the speed is going to equal to 10 cubed plus 10 squared minus 10. So this is 3,100 minus 10. So we have 3090 speed, which is centimeters per second. This is centimeters per second there. So that's a speed, 10 seconds. All right, next question, right? This other question says, find the distance covered by the chalk between 5 to 10 seconds. Express your answers to the nearest whole number. All right, the distance, right? The distance is equal to the integral of your velocity, right? So, which means that the distance that we're going for is going to be the integral of 3t to the third plus t squared minus t. We're going to have to do this dt. So let's go for it now. So the distance, yeah, the distance is now equal to 3t to the fourth over 4 plus t to the third over 3 minus t squared over 2. And we're moving from 5 to 10. So no constant is needed there. So let's work this out. Distance, I'm just going to call that d. It's going to equal to 3, 10 to the fourth over 4 plus 10 to the third over 3 minus 10 square over 2. And we want to subtract 3, 5 to the fourth over 4 plus 5 third over 3 minus 5 square over 2. All right, so we want to work out those values. All right, so we want to work these out quickly. All right, so we have 10,000 times 3 and divide that by 4. All right, so we have this little piece is 7,005. All right. 1,000 divided by 3. This piece is 30. So we have 333.3. 100 divided by 2 is 50. This is a 50. And subtract. Let's see what we get here. 5 raised to the fourth. 625 times 3 divided by 4. This is 468.75. 5 cubed, 125 divided by 3. And that's like plus 41.67. And 25 divided by 2. 12 and a half minus 12 and a half. All right, so let us work this out. 7,500 plus 3.3 minus 50. And we're going to subtract, change the sign of those. So we're going to minus 468.75. We're going to minus 41.67, but we're going to be adding 12.5. All right, so I'm getting 785.38. But to the nearest whole number, I'm getting 7.285 centimeters. Right? So to the nearest whole number, that's what I'm getting right there. All right, looks all right. Looks all right. Let's move on. All right, so now we have, want to find the integral of this. All right, so the integral of, want to integrate 2x plus 3 squared dx. You could expand this, or you could work this backwards. So what happened is, first, we're going to have this, and you're going to increase the power, comes 3. You divide this by that 3. And ordinarily, you would have multiplied by this, but in the integral, you're going to divide by it, so it becomes there. So what we're looking at here, and then there's a plus c. All right. So what we're looking at here is this. Finally, our answer is 2x plus 3 raised to the third over 6, and there's a plus c. So that's the integral for that. All right, for this one now, we are integrating 5 cos 2x dx. We could move the 5 out of the way. So basically, we are integrating cos 2x dx, because when we have a constant, it's not going to change anything. You understand? So basically then, our final thing is to understand that 5 is always there. The integral of cos is going to be sine. So it's going to be sine of the same angle. Right? And then ordinarily, you would have multiplied by this. So in the integral, you'll divide. So this becomes divided by 2. So the final response, there's a plus c here. The final response is to have 5 over 2. And then you have sine 2x. And there's a plus c. Right? So there you go. That's the integral of that. All right. Final one. It says dy dx is 6x minus 10 and y is equal to 12 when x equal to 0. Find the equation. All right. In terms of x and y. All right. If I have the differential, I need to integrate. So I'm going to have to integrate this. So if I'm going back to the regular, if I want to know the original equation, I'm going to take the integral of this, right? We're going to have to take the integral. All right, so when I integrate this, here's where I'm going now. This is going to be, y is going to be equal to, this is going to be 6x squared over 2 minus 10x plus c. If I simplify this, y is equal to 3x squared minus 10x plus c. So now, in order to know what c is, I'm going to take this point here because this is the point 0, 12. But the fact that I have is 0, 12, right? I'm not going to work out this because for every y-intercept, you have to cross the x-axis at 0. That means this c value is 12 without working, all right? Because I'm utilizing the fact that if I cross the y-axis, I am at 0 on x. So I don't need to prove that I'm going to get 12 because this is my y, this is the coordinate. This is actually the coordinate of the y-intercept because the x value is a 0. Therefore, the equation is y is equal to 3x squared minus 10x plus 12. That's it. And the reason why I could draw that conclusion again is because for every y-intercept, the x value is a 0. And I'm seeing that here. That means I'm at my end. All right. There you go.